So you'll see that I've written down a little summary on this page because I think this page is quite a good go-to to see just if you want to briefly have a look at the equations. So the three gas laws are P1V1 equals P2V2 with a constant temperature and mass. P1 over T1 equals P2 over T2 with a constant volume and mass. And V1 over T1 equals V2 over T2 with a constant pressure and mass. Okay, I've also just written down the relationships. So pressure is inversely proportional to volume, or is proportional to 1 over volume. Pressure is proportional to temperature, and volume is proportional to temperature. So I would suggest you write all those down because it's quite a good way just to very briefly glance at and see what the relationships are and what the constants are. So if you wanted to prove the relationship, you would do P times V is constant. P divided by T in Kelvin is constant. V divided by T in Kelvin is constant. Okay, so make sure you've got all that written down. Can you got it written down? And the combined gas law is literally just combining them all together. So the top one is Boyle's law, the second one is pressure law, and the third one is Charles's law, which we just did. Luckily, you don't really need to remember all of those equations because the combined gas law puts them all in one equation and it's easy to use. It gives you the combined gas law. Separate ones, no, but I'll tell you why it's really easy to work them out. Okay. So what they've done is they've combined these three. So P times V, P divided by T and V divided by T, they're all constant. So they can combine them to show you P times V divided by T, that's all them combined into one, is a constant for a fixed mass of gas. Okay, so PV over T is constants. So if you were doing an experiment with all three of them, if you times P and V and then divide it by T, you'd get constant, you get the same value over and over again depending on your results. So we can create an equation from that. So instead of P1 times V1 equals P2 times V2, P1 divided by T1 equals P2 divided by T2, we've got this final lovely big equation here, which is given to you in your equation list. This one here. Okay, so this combines them all. So if you had just pressure and temperature, not volume, you can just cover up the V's and you get P divided by T. So you just cover up the one that you don't want, basically. So all three of them are in one equation. So you don't need to memorize the three separate equations because you've got that big one given to you in the equation list. So if you wanted P and V but not T, just cover up the T's. You've got P1 V1 equals P2 V2. Okay? So an example now, the worst part about this is you've got three different variables, well 6 different variables. Okay? So you just got to keep an eye on which one's which. So a balloon of gas of a temperature 7 degrees C, remember we need to change it to Kelvin, has a volume of 0.1 meters cubed when at a pressure of 100 kilopascals. This balloon is gently heated to a new temperature of 87 degrees C and allowed to expand to a volume of 0.15 meters cubed. Calculate the new pressure. Okay, so we want P2. We've been given all the others here. So we know the equation is P1
V1 over T1 equals P2 V2 over T2. So what have we got? P1, the initial pressure is 100 kilopascals. So I'm going to change it into pascals, but you don't necessarily need to as long as you remember it is in kilopascals. Your answers will be in kilopascals. V1, the initial volume, is going to be 0.10 meters cubed. Initial temperature is 7 degrees C. So we need to change that into Kelvin. So it's add 273. So 273 plus 7 is 280 K. P2, V2, and T2. P2 is what we want to find. The second volume is 0.15 meters cubed. And the second temperature is 87 degrees C. So we have to add 273 to that to get Kelvin. So that's degrees C. So 273 plus 87 is 360 Kelvin. And then you just put them all into your equation. So first thing first, put all the numbers in, work out as much as you can. You cannot exclude the volume at this point because volume isn't constant. If the volume was constant, you could. But because it's changing, you have to include them all. If all three are changing, you have to include all three. So 100,000 times by V1, so 0.1, divided by initial temperature equals P2 times by 0.15 divided by 360. Okay, so what I would do is work out that left-hand side first of all. So, yeah, 35.714 is it? Yeah. Oh, probably more. Equals P2 times 0.15 over 360. Okay, so again, if you want to simplify it even more, you can work out what 0.15 divided by 360 is. And then you've only got three terms. So can you take it from there? Let's see if we all get the same answer. Because they're all times, if they were added, yes, but no, because they're times together, no, you can separate it out. So your answer should be about 86,000. So I got 85 right underneath. $85,700 pascals. Did everybody else get that? 0.15 divided by 360. That's absolutely fine. Yep. You get the same answer? Yeah, sure. That would probably only be 3 marks, I'm afraid, because it's just equation, numbers, final answer.